Hello, my name is Colin Doyle and I'm a Senior Systems Engineer at Juniper Networks. This is the second video in a series that demonstrates to the viewer how to install, configure, and operate a Juniper Cloud CSO SD-WAN spoke test environment on their own laptop or desktop computer. In my first video, I provided an overview of this series and discussed some important considerations and caveats. If you have not watched that video, I would encourage you to do so now. In this video, we'll be installing our WAN emulator and link conditioning virtual machine. We'll start by configuring the hypervisor interfaces required to create our WAN service chain. We'll then create our guest VM from a vmdk file, and finally, we'll install and configure the necessary packages to bridge our WAN interfaces and perform link conditioning. Let's begin. You might be noticing that I have more virtual machines here than I should. And that's because while recording the 6th video in this series, I realized I had made a mistake in this video during the creation of my interfaces that prevented the RPI WAN client from providing link conditioning services to the VSRX gateway. Rather than tear the entire environment down, I'm going to walk through the creation of the interfaces and then delete and recreate the RPI WAN client. Let's start by getting into the VMware Fusion preferences and then selecting Network. There are 5 interfaces that need to be created for this lab: LAN-VM, WAN-0, and WAN-1. We also need to create WAN-0_bridge and WAN-1_bridge. The LAN-VM, WAN-0, and WAN-1 interfaces are all created with all checkboxes cleared. WAN-0 bridge and WAN-1 bridge will be providing a connection to the network using NAT, connecting the host MAC, and providing DHCP. So be sure to check those 3 boxes. The subnet IP that you use is at your discretion. I use 10.0.0.0/24 and 10.0.1.0/24. Fusion does not expose any of the other DHCP configuration through the GUI, and I found no easy way to make changes to it in the CLI. What I have found is that the gateway address will almost always be .2. In fact, I haven't found a situation where it isn't. But please check once you've configured everything and you connect your VSRX in a later video. You'll want to verify just for your own edification what that gateway is. I've also found the DHCP addresses that are assigned to be sticky through multiple restarts over the course of months. So while I have no way of defining static assignments, that IP address that it hands out to the VSRX will remain the same. Once your interfaces are created, click Apply, and let's move on to deploying the RPI WAN client. I'll start by deleting mine. You obviously don't have to take this step. And we're going to download from the osboxes.org website a pre-built vmdk file. Make sure that you download the VMware version. I'm using 2019-0411. You can use the most current version. This is just the one that was available when I downloaded this file and started this lab. I've already downloaded the file, and the link to that can be found within the companion document. Click plus, click new, and then create custom machine. Keep the default Linux 4.0. Use a legacy BIOS, and then select the vmdk that you've downloaded. Now click Continue and click Finish and give your virtual machine a name. Once the VM is provisioned, Fusion will attempt to start it. We'll want to stop this boot process and make a few more changes before our first boot. Right-click, go to Settings, and adjust the memory to be 1024. I don't think this is strictly required, but I found this value to provide stable operation. Now let's add our network interfaces. Our first network interface is connected to the WAN-0_bridge. We'll add a second one, connect that to the WAN-1 bridge. And a third, connected to WAN-0. And a fourth, connected to WAN-1. Now that this is complete, close the window and boot the virtual machine. The reason I like using a pre-built vmdk file is that installation of Raspbian, and anybody watching that's done this knows this to be true, takes a while to build from a package. Whether it's on hardware or software, it's still pretty involved. It can take some time. One consideration when downloading this vmdk file is that the password has already been set. In this case, the domain of the website. So when you do get your login screen, type osboxes.org. Of course, we're going to want to change that password, as well as change the host name and set the time zone. So we'll do that here. Eventually, once the client catches up with us. Come on. Oh, killing me, Smalls. There we are. Let's change the host name to RPI. Change the password to whatever you like. Oh. Let me guess. Right. Because I didn't wait long enough. There we go. And then change your time zone. Once this is done, reboot the VM. Once we get back into the Pi, we're going to make a modification to the host file that will speed up greatly the usage of the sudo command. And you'll get to see this difference in real time. I can't explain succinctly why this is required. I'm sure somebody watching this video can. Feel free to mention it in the comments. But trust me, you want to do this first. Now I've hit enter, and you'll note that there is a pause here. This is what we're sorting out. And yes, it does take this long until you put this configuration in. It's maddening. All right. So we're just going to add the name of the host that we just configured to these two lines. And then we're going to save and exit. Now you'll note that if I run this command again immediately, it brings it right up. That's why you do this first. Next, we're going to update our apt-get libraries and prepare the system to install our WAN emulation software and bridge utilities. We're going to use a package called bridge utils to create a bridge between the interfaces that are connected through NAT to the public internet and to our VSRX. This bridge will allow us to use link conditioning software called TC, or traffic control, on that bridge, specifically the member interfaces of that bridge, to introduce jitter, latency, packet loss, packet corruption, and a number of other ugly things that will trigger SLA actions and do application-based switchover. The bridge utils package includes the TC package as well, so we only really need to install this one thing. We'll then configure our interfaces for bridging. Let's back up our interfaces configuration first, just in case. Now we're going to add some lines of code that will bridge our interfaces together. Now we'll create the bridge. Here we define a logical bridge and we assign bridge ports to that bridge. Once your configuration is complete, save and quit. And remember that this configuration can also be found in the companion document to this video series. Now we can restart the networking service or simply reboot the system to confirm the changes have taken effect. I prefer reboots. I like to swing the big hammer to make sure everything is happy. Plus, I don't remember the networking restart commands for Raspbian off the top of my head. Now what we'll be looking for here after the reboot is to confirm that we have a BR0 and BR1 interface, and that we have IP addresses that have been assigned from the hypervisor on the subnets that we defined earlier. Here we see BR0 and BR1. We can also confirm that we have IP addresses. That's all the work that we need to do with our RPI WAN client for now. Thank you so much for your time. Thank you for watching. And now that I've also finished recording the series, I can tell you that it's pretty fun and worth it. So I hope you can make it through to the end. If you have any questions, as always, leave them in the comments below or reach out to me directly. And thank you again for joining me today.